that from -4 to 4, I have a semicircle, right? But the integral is saying only calculate it from -4 to 0. That corresponds to that area, right? So if I'm using areas to do this, I'm not like evaluating the integral at all. I'm just using areas. Well, I guess I am, but I'm using areas. I'd have pi r squared, but I have to divide it by 4 because I only have 1/4 of the entire circle. So this would be 16, right? 16 divided by 4 is 4 pi. Units squared. So use area to find this integral. I think maybe the easiest thing is to graph it first. And I'll give you a hint on the graph in like 30 seconds. My hint would be that this is the same thing as negative absolute value of x plus 1. That's what I would think of. Just so I know, like, oh, it's flipped over and shifted up once. All right, so for this, I think for me, since I'm using area, it's easiest to think about this if I have a graph. And I know that the normal absolute value function looks something like that. But this one is flipped over the x-axis and shifted up 1. Is that true? I hope so. But I'm going to, maybe I don't even know. I'm going to double check by plugging in points. If I plug in 1, I should get 0, right? Yes, that happens. If I plug in 0, I get 1. If I plug in 2, I get -1. Yeah, this works. So if I'm getting the area from, ooh, a green line. What is that? Wait. I've never done this before. Is it only recording? No. Well, I am recording, but I'm curious to see what the video looks like. Okay, so sorry. Let's do this. That would be from -1 to 1. That's just, is that 1? Units squared? Because the base of the triangle is 2. 1/2 times 2 times the height of 1. Or you could do 2 triangles. This is a half, this is a half, add them together, it's a whole. It doesn't matter. You can change those to x's. Right? It's just like, whoop, whoop. See, you can change it to x. No, I mean it also doesn't change the meaning of the problem if you change it to x's. Yeah, use area to find this. It's actually not so bad. The hint is you're graphing y equals alpha, which is the same thing as y equals x if you change those to x's. And then you're finding the area from pi over 2 to pi. I know that, first of all, the graph that I'm looking at is this. Y equals alpha, not infinity. Alpha. Where this is my alpha axis, this is my y axis. And I'm going from pi over 2 to pi. How much distance is that? It's pi over 2, right? Because you need another half. And then also, if I plug in pi over 2, what do I get out? Pi over 2. So if I plug in pi, I get out pi. Area of this and area of that added together. All right, so for this, if you graphed it, you would see this. It's easiest to get the areas separately and then just add them together. This is pi over 2 by pi over 2, so that's just pi squared over 4, right? If you just square it, pi over 2 times pi over 2 is pi squared over 4. And then I'm adding 1/2 times the base times the height of this, right? So then that's just pi squared over 8. Get a common denominator. So 2 pi squared over 8 plus pi squared over 8. 3 pi squared over. Is that what we got? Units squared?